tutorial. Subject name is compiler design. Previously we discussed the syntax directed translation and the statements of three address code notation. Now here we'll see the concept of today. What is the different types of three address code notations and the statements followed. What are the different types of three address code? So outcome is to understand various types of these three address code statements. And the topic learning outcome is demonstrate the different types of three address code and statements with that implementation. How it can be implemented by using this. Let us see the concept of three address code notation. We have seen this how three address code is verified and maintained. That is a three address code that is to be generated with the help of a statement syntax notation. That is, it contains maximum one operator, minimum at least three operators, three operates and one operator. This thing we discussed in the previous class. Now, what are the different, now we will see in this concept, what are the three representatives. There are three representations out there to represent this three address code. Actual syntax is that at least one operator and three operates that is to be required, at most three operates. Now, first one is quadruple notation, second one is a triple representation, and third one is indirect triple representation. These are the three representations of the three address code: quadruple, triple, and indirect triple representations. Here, the first one, the quadruple representation. In this quadruple representation, here the instruction, each instruction, it is to be divided or split into four different fields. So here, what are the four different fields that are available in quadruple representation? One of the field, it is an operator. This is called as operator. And another one is one argument, that is operand 1. Another argument, that is operand 2. And the result. Result means when we perform the expression, that is operand to be stored. Now, we told that three or at most three operands, one operator. So as per this, the syntax we have given. Now, that means first, second, third, fourth. That means operand, argument 1, argument 2, and result. These four fields which are necessary and required to represent the quadruple representation of the information. So first is operation field, internal operator. What is the storing of the operator? Whether it is a plus, minus, any operators, etc. Argument and argument fields are what is the data that is to be used for storing the content. So this is data 1, data 2. Now the result field, that means the operation that is to be performed on. So suppose if it is a plus, data 1 plus data 2. That means this is argument 1, that is this is operator OP, this is argument 1 and data 2 is argument. Now we are performing operation. So here we will get some data. We will get some more data. After performing the plus operation, we will get some. So this data is nothing but result. This data is nothing but result. Let us see an example how this This is the syntax of representing this quadruple notation. Now through an example, clearly we will understand what is this quadruple representation information. Some of the advantages and disadvantages which are related to this quadruple representation. So we know that a quadruple representation contains 4 fields, that is operator, argument 1, argument 2 and result. So we know that this operator is to be performed in between argument 1 and argument 2, whereas the result that is to be stored inside and result of the expression. The first most advantage here it is rearranging the code for global optimization. The first and foremost important point is it is easy to arrange the code for global optimization purpose. And we can also, whenever required any data from that can be accessed easily. That means fastly we can access that data of temporary variables using symbol table notation also. That is the main advantages of the quadruple representation. And some of the flaws are also available. That means whenever we represent this type of representation, generally we can use a different temporaries. Lot of temporary variables are required. So that consumes more space, and also processing time also requires. So that is the main problem with this quadruple representation. Okay, these are the main pros and cons of this quadruple representation. Let us see an example how this can be implemented. So we have given one expression. See here the problem statement is the given expression. Translate the given expression into quadruple representation, triple representation, and see, first of all, we know that a representation is a quadruple representation which contains operator, argument 1, argument 2 and result. So this notation we have to represent in terms of this quadruple. But here in the given expression, you see this is an operand. Operands are how many? So there will be operands A, B, C. Operands are there 1, 2, 3, 4, 5 operands, and operators are into, minus, plus, into. These are all operators. But according to the syntax defining the quadruple representation, this 3 address code, 1 operator is required, at most 3 operators. So it should satisfy the first 3 address code notation, then we can represent this. Okay, like this here in this example. That's why we have to translate the given into a notation, 3 address code notation. First representation, that is quadruple representation. So whenever you try to identify more number of operators and operators compared to the given syntax structure, then we have to break down that expression into further small 2 more expressions. So for example here, unary minus C, that is to be considered as 1 temporary. So that is to be considered as T1. And what happens? A equal to, what is next? If you consider this T1, next B into T1, you can take 1 more temporary. That is next. You take 1 more temporary T, that is T3. So here T1 is 1 and T2 is, T1 is 1 and T2 is something, that is B into T1, and next we are taking a T3 which is equal to minus C, then B into T3, we will get 1 more temporary, and then result. So T2 plus T4. and the result is stored in one more temporary, that is assigned with some A. So A equal to T5. This is the, here the expression is, whenever you say T1 equal to minus unary minus C, unary minus C. Now the, according to the syntax structure, we are going to see that this run into a syntax table structure, quadruple representation in the next slide. See here, each one we have to write a separate column with operator, argument and list one. So that's why here all the list of the contents which are given, sub expressions we have considered. So each is to be considered as a 3 address code notation. We have to convert the expression into a smaller sub expression with a valid, these are all valid 3 address code notations. Otherwise it is not able to represent inside quadruple. So only 3 address code notations only we can represent inside this notation. So that's why we have converted and each representation as a 3. We know what is 3 address code. In the previous class we have discussed about what is the syntax of 3 address code. At most 3 operands, at most at least one operator is required to represent a 3 address code notation. So after performing this procedure, now let us go through quickly the representation. Here we know that operator is one column, argument 1 is another column, argument 2 and the result. So for each expression we have to list out the constants. Say for example T1 equal to U minus C. U minus C. Now here in this first we have to consider T1 equal to U minus C. For example, what is the operator here we are performing in this expression? Unary minus. So that's why I have taken unary minus operator. And what is the argument we share? First argument C. There is no another argument, that's why we are keeping it as a empty. If there is argument present, we are going to list out that one in the corresponding entry, else keep it simply empty. And then result is stored in T1. So that is one more entry. So that is the 3 columns. That is the 4 columns. Or 3 columns listed out of these 4 entries. Now like that we have to write that is considered as a first row of the expression, that is T1 equal to U minus C. Then for second row, if you consider the second expression T2 equal to B into T1. T2 equal to B into T. In this expression, what is the operator we are performing here? Into operation. So that is to be listed out as a OP column. And what are the arguments? This is one argument, this is another argument. So B is 1, T is one argument and the result is stored in where? T2. So that's why here we have written T2. And similarly the third expression, if you consider T3 equal to unary minus C. So which is same as equivalent to the first one. So unary minus is the operator, C is one argument, there is no second argument and the result is stored in T3. And the next expression, that is T4 equal to B into T3. Now in this the expression, let us see the content, that is operator is into, argument 1 is B, here second argument is T3 and result is stored in another argument, that is T4. And another expression, that is T5 equal to T2 plus T4. In this also the quadruple is represented as a row pattern, that is plus operator, T2 is one argument, T4 is another argument and the result is stored in T5. Result is stored in T5. Now T6, that is the A equal to T5. So here there is only operator, that is assignment operator, and argument 1 there is no argument 2 and the result is stored in assigned to A. So that's why it is given. So like this, how many expressions, the given expression first can be translated easily into a 3 address. If it is already in 3 address code, then there is no need, directly we can represent as a quadruple representation. If not, we can break down that structure into a similar group of expression where the valid of 3 address code notation, then only we can go through the representation of this row column notation, table format, and in this way, we can represent all sub-expressions of that quadruple representation. So here, main important one is it contains 4 columns. One is operator, second one is another one is argument 1, third one is argument 2, and performing the result storage is argument operator, another operator. Now let us see quickly the another representation. 2 representation. Almost we know that there are 3 representation: quadruple, triple, and indirect triple. Now here in triple representation, we have seen quadruple. Now second most is triple representation. So here we are going to write a reference to the instruction. Instead of writing, we are going to write a reference to the, that means previously we have written the arguments list, but here where is the instruction? That reference is to be written, and instead of temporaries. So temporaries we don't. Previously we have used what? T2, T1, T3. So instead of T1, T2, we are going to use, instead of the temporaries, a reference is to be given. So what is the reference? How it will, you will see through the example. And third one is indirect triple representation. This is same as triple representation, indirect triple. So here triple is compared to the quadruple somewhat the same table, but instead of temporaries we are replacing what? A reference to the instruction. So indirect triple is somewhat advanced compared to the triple. It is same as that representation, but what is the enhancement over triple representation is it uses some pointer notations, pointer to the triple in the order. So we are going to give a link or pointing notation where the reference of the instruction takes place. So that is the place where the pointers are to be used to store the result. So instead of position, we are going to give what? Pointers, which is used to store the result. And it easily allows to optimize and reposition the sub-expression producing the optimized code. We can perform that to reposition the sub-expressions and producing the optimization purpose. This code will be used. So let's quickly go through an example how this reference of the instruction takes place in case of triple representation, and how the pointers are assigned not to store the results and then get this representation of the information through an example. See here in this example, this is a previous example only we have taken, but what happens, see here T1 equal to U minus C. But here the operator is U minus, that's why I have taken, and argument is C, that's why one argument, and the result is stored in T1. But here we are not writing T1. So instead of writing what T1, we are going to write reference. But here previously, here we are writing result T1. The quadruple representation, we are writing T1. But here we are not writing the T1 in the result. So instead of writing the result T1, we are writing a location reference. That means where the T1 is, where T1 is stored, that value reference of that instruction. So that location reference instruction is to be written. So that is the where in triple reference to the instruction is to be made instead of temporal. So here we are not using T1, T2. Instead of T1, a location reference is to be introduced. And then the second expression, that is T2 equal to B into T1. So we have to write an operator same, and there is no change in the listing out the operators. You observe that only the reference only the difference arises where T1, T2 will be mentioned compared to the previous table. That is quadruple representation. Here the another argument is, one argument is B we have written. Here another argument is T1. So but we are not writing temporaries. So instead of temporaries, what? We have to consider the reference. So here where the reference came from the first. That is the first location. So that's why I have given first. one reference instruction, one where it is the result is stored. So it will take the result from that T1 where it is stored. That is to be taken and then processed with the operator and then multiplied with B. Then result is stored in one more, that is temporary. So here instead of temporary we will give reference. So that reference is a second reference. So like this another expression, suppose T3 equal to U minus C. So this is same as the first expression, that is operator minus argument 1 and the result. Instead of temporary where we have taken, we are going to take a reference. So that is 3 reference. Next T4 equal to B into T3. Now here operator is into B is one argument. Instead of T3 we are writing the reference 3. Instead of T4 we are writing a reference 4. Next T5 equal to T2 plus T4. T2 plus T4. So here operator is plus. So that's why I have written plus. But what is the temporary T? Instead of T2 we have to write what? A reference, 2 reference. T4 is also a reference. Previously we got this one. So T2 to T4 we are getting both the reference from the previous system. So that T2 T4 reference is to be written as 2 and 4. And finally A equal to T5. So here assignment and then A. What is A? It is argument 1 and there is no argument 2 and the reference is stored in another reference. So here T5 is reference. T5 is reference. So that is to be written and that is stored in one more reference 6. So previous reference 5 have considered and then it is stored in 6. So like this we have to consider the argument operator or argument 1, argument 2. Only the difference is here the location difference. So that's why all the temporaries are eliminated. Instead of temporaries we are writing only the location reference. That is the one of the difference between this quadruple and triple representation. Now indirect triple. See here we have taken this table location operator, the same table which is available here as a triple representation also. This is a triple representation which we got from the previous slide, that is triple representation. That is T1 equal to unary minus C, that is B into T1 equal to T2, T3 equal to unary minus C, and here T4 equal to B into T3, T5 equal to T2 plus T4, and A equal to T5. So these are the listed out 3 address statement for each of the row entries. Now in the case of indirect triple representation, now we know the triple representation. Indirect representation, what happens? We have to take a memory address where the that is pointer to reference address, reference instruction. So here it is saying that we have to take an additional instruction where pointer to a triple representation. So we are going to use a pointer to store that result. So here in the pointers, what is the here first instruction is to be, so here first statement, so that is to be represented, and the second statement pointer to address location 36 location, 37 location, this 3, and 38 location 4, 39 5, 40 some. So we are going to write some memory location addresses with all the reference of the instruction with the pointers, so that it automatically gives a reference to that particular instruction and goes to the particular location, and then it verifies the result, perform the operation, and once again retrace that one. So this is a format of indirect triple representation. This is the format of indirect triple representations. So only the difference is same we are going to write, but only two entries. One is reference instruction and the memory address where it is stored, and this pointer to address location is to be taken place as a column entry. Two columns are to be separately written. So in this is a very simplified table compared to the previous two tables. Only you have to write the address where the pointer is location. So that is to be reference to this corresponding three address statement, and it gives the big back result to that particular location, and the corresponding statement has been executed. Similarly, second one is also like that. We have to give all the references for that one memory location which is given up, which is to the pointer to the particular location. And now we know that three address statement, but different types of these three address statements are also available. That means at most three operands, at most one operand. So in that case, first we know what is assignment statement. Different types of three address statements are there. In that, one of the type is assignment statement. Here in this assignment statement, the syntax is XOPY. So X, Y are the, here we have written X, Y, Z are the operands, and OP is nothing but operator. So we can perform. So previously I said T1 equal to unary minus C. So this is an operator, operand 1, operand 2. Like that an assignment statement can be written. So here the result is to be calculated. That means performing Y, Z. So here Y value may be 3, operator plus Z value 4. So that is equal to 7. So X equal to 7. So like this, the result is to be assigned by using equal to operator. So here equal to, that is indicating that result assignment. Result is assigned after solving the right hand side of the expression, assignment to the left hand side. So assignment simply saying that whatever the value that is computed on the right hand side, that is to be assigned to the simply to the left hand side. This is one type of a three address statement. Another type of three address statement is a copy statement. That means here we are assigning some value. That means X equal to 5. The 5 is assigned to X. So here just this is also an assignment operator where X and Y are the operands. Here in this statement X equal to Y, X and Y are the operands, and equal to is assignment operator. So here equal to, in the case of X equal to Y, equal to is assignment operator. That means simply we are assigning the value of Y to X. Assign value of Y to X. So that is right hand side of the expression computed. But here right side of the side consider sometimes there will be a large expression or small. But if there is no operators or only one operand is available, then at that time it simply takes that value, that is whether it is 5 or X, any value, that is to be simply assigned to the left hand side. So left hand side may be at least contain only one. So that's why here in this case Y is available, only Y is assigned to X. So if any other expression is available, it computes and then yes. So this type of statement is called as copy statement. And procedure calls are also used as one type of three address statement. The procedure calls takes a parameter. That means it is a function type of the procedure where accepting the invocation of this procedure takes place with some parameter. The parameter may be arguments, different arguments, argument 1, argument 2, and it returns some value. That means after executing this function, it returns some value. So that return value is to be carried out using the result Y. So that's why Y equal to callback, and X parameter X is to be used as parameter. So this is also one of the notation for representing a three addressed statement. Fourth one is another one, that is conditional jump. Here the expression is if X relational operator y, x relational operator y. So we know that various relational operators such as less than, greater than, less than, equal to, greater than, equal to, not equal to, like that. Some relational operators are to be used between any two operands. So here operands are x is one operand, another one is y is another operand. So if these two operands are to be performed with some operator, that is a relational operator, and that is to be assigned as a one statement. So that is to be that result is to be passed, and that means condition satisfied. Since it is a if statement, if that result satisfies, then the corresponding goto will be executed. If that condition gets satisfied, that the condition x satisfied means, suppose if x less than y, then in this case the directly the statements, what are the statement that is specified by this label x, go to x, maybe x contains some other statements, so that list of statements are to be executed, and remaining all the statements between this will be skipped. That means here if followed by, suppose for example, if x relational operator y go to x. Suppose if this condition is the contains list of statements, x also contains some list of statements. Whenever this is satisfied, then it skipped off the statements following, and control goes directly the x very available, and those statements are to be executed. So that is the meaning of x relational operator y go to x. All these statements will be skipped where x is available, that is to be executed. Suppose if the condition fails, that means previous case, first case it is passed. Suppose in this case it is failed, that means there is a condition, there is no x less than y or a different false condition, then it doesn't go to x. The control is, that means it doesn't send the control to the label specified. That means it won't execute the label x. Instead that, what is the statement which are immediately available? So these statements are to be executed. Previous statement, instead of going x, it won't go to x. So here false, x relational operator y, it is false. Then it won't go to the this x label x, and then it directly invokes the remaining statements, the following statements of if, that is to be executed. This is also one of the 300 statement which comes in, that is a representation. Here conditional jump specified, based on the condition only it will jump to the particular location, else it won't jump and it will remain as it is in that location, and following statements are keep on continues to exist for that location, for that point. And another one is unconditional jump. That means we are not going to verify any statement. In the previous, we are going to verify with some operator and checking the condition whether it is true or false. But here we are not checking whether it is true or false. Directly go to x. That means based on the directly go to that particular executor, and control is sent directly to the location specified x. It doesn't see whether that previous one is like previous x less than y, like that. All the statements are to be skipped remaining, and then it executes. And where this procedure call, another type of three-letter statement, where parameter x call p return. It is like a function calling only. So call p, we are going to for defining the function with some arguments, that is parameter x, y, and this function returns some value. So that returns value is to be calculated as y. So p is a function and x is a parameter and returns value is y. So this is one of the syntax procedure for procedure call in some of the programming languages like Pascal and some other programming languages, where we can invoke a function with some return value by accepting the arguments as this one. So here the contents which are to be available, all the contents are to be considered from this book, that is Compilers, Principles, Techniques, Alfred, City and Woolman. And today we have discussed about the concept that is called as three address code notation, which contains three representations. One is a quadruple representation, second one is a triple representation, and third one is indirect triple representation. Quadruple representation, which contains four parameters, that is to be represented as operator, argument 1, argument 2, and the result. Whereas triple representation, simply we are going to write a reference of the instruction instead of temporaries, remaining same as it is at the for the quadruple representation. Whereas indirect triple, simply you are writing a two-column notation where one column represents any number which is representing the corresponding statement, and second one is that statement notation is given as a pointer to that particular location specified instruction. It retraces the corresponding value. So like that, the two-column represent is same as the triple representation only. Only instead of reference of the instruction, we are giving pointer to the reference to the instruction. So, and then finally we have described about general types of three address statement: assignment statement, copy statement, and then procedure calls, conditional jump. Based on the condition, we are going to jump particular instruction, and unconditional jump, where without checking any condition, directly it goes to the particular location and specified instructions are to be executed, and then procedure calls with the format. So these things are available. You can find out in the book, that is Alfred City Woolman. And next we are coming with one more new topic. Till then, okay, thank you. Now we are closing this session. Next we'll come with a new topic. Once again, thank you, Alaf. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.